All right, so number five says a $32,000 car you just purchased will depreciate by 15% per year. So if you don't know this already, when you buy a new car, the second you drive it off the lot, it's no longer quote-unquote new, so that decreases in value. And that's what that word depreciate means, is that word depreciate, and let's go ahead and define that. Depreciate means to go down in value. So we could say it goes down in value. It's not worth as much, right? If something goes down in value, it's not worth as much. So it goes down in value. So right there, that word, the fact that it's decreasing, that it's going down, that tells me that I'm not talking about something that's growing, I'm not talking about something that's getting bigger, I'm talking about something that's decaying, something that's getting smaller. So that's where we're going to use the formula that they're on the right. We still want to define our initial amount. So our initial amount says we're starting off with a $32,000 car. So that's our initial amount right there, $32,000. We still want to identify the rate, how it's changing. So it says a rate of 15%. So that would be our R, right? So that in this case it would be not the growth rate, it would be the decay rate. And then we want to just know the time interval. Well, we're first of all just setting this up, just similar to like what we did in one of the previous questions there. Set up the formula first, and then we'll actually go about answering it. So let's say that we've got, there we go. Let's say that we've got y equals our initial amount, right? Where it's starting at, 32,000, times how it's changing. And how it's changing is that it's not getting bigger, it's getting smaller. What's it getting smaller by? By 15%. So 15 cents would be 0.15. And then that would be to the t. Right. I could go ahead and combine this. So what I'll do is I'll say y equals 32,000. 1 minus 15 cents, so if I had $1 minus 15 cents, that would be 85 cents. Right? And I could check that because if I added 15 cents to 85 cents, I'd get $1, right? So, and then this would be to t. So that would give me the equation I wanted for part A. Now for part B, I'm just plugging the number in. So it says to use for time, what it's saying is that what would that car be worth in 7 years? Well, it's going to be worth a lot less than $32,000 because now it's a used car. So this would be our time interval. And we're really just taking what we got from part A, 32,000 times 0.85, and then we'll see that the time would be 7, right, for years. And then let's just plug that into the calculator to see what we get. So we'll take 32,000, clear this out, 32,000 times 0.85, and that's raise the roof to the 7th power. So it looks like 10,000, we're talking about money here, so 10,000 258, and then we'll just put the change on there. So it looks like 46. There's a 6, so we'll round that to a 7. Don't worry too much about the rounding. But it's approximately $10,258, which is about right. You buy a car new, 7 years down the road, it's not worth what you paid for it. It's worth a lot less. One other thing to note real quick before we move on is the value of the number that's inside this parentheses. Notice that what happens is that when we're talking about a growth situation, like we were in 3 and 4, you see that this number is greater than 1, right? Because it's not, remember, 1 represents where it is, and then the plus or minus represents how it's changing. So if it's greater than 1, that means that it's growing, that we're talking about exponential decay. If this number that's in parentheses is less than 1, then we're talking about decay. We're talking about something that's getting smaller. All right, so go ahead and stop the video, and let's try number 5 on the right side.